In this video, we are going over the Got It number 1 in lesson 8.4, and we are comparing linear functions. Okay, so the Got It number 1, make sure you've tried this before you watch the video. The Got It number 1 says relationship A is defined by the equation y equals 9x. That's important. Some of the values of relationship B are shown in the table below. Both relationships represent a direct proportion between x and y. And what that means, a direct proportion is basically telling you, those words mean that this is a linear function. Okay, because a direct proportion, I put in parentheses to help you out. It says meaning it's a straight line that goes to the origin and the slope is constant. All right, what that means is that the ratio between the two quantities, x and y, is constant. Okay, so this would be a straight line. All right, so here we have, all right, so they gave us relationship A, I'm just going to put it down here, is y equals 9x. And then relationship B, they give us the table of values. And we have to figure out which relationship has a greater rate of change and which relationship has the greater initial value. Okay, well, the rate of change is like the slope, right? And the initial value is like the y-intercept. Okay, so let's see here. Well, let's find the rate of change of both of the functions first. The equation is probably easier, right? We have the rate of change here is the same thing as the slope, which is the number with the x, number with the variable here. So the answer is, for the rate of change for relationship A is 9. Okay. Now let's find the the rate of change for relationship B. All right. So we have some points, right? We think of a table of values as points on a graph, 0, 0. So you could see that this line is going to go through the origin. It's going to be a straight line going through the origin. Then you would have your point 3, 34.5, 5, 57.5, and 8, 92. If you were to graph these ordered pairs that coincide with our table of values, these would make a straight line that goes to the origin. Okay? So, now we define the rate of change. All right, remember the rate of change is the change in output over the change in input okay? Our x is our input, our y is our output. All right, and now we have to find the rate of change between any two of the points. All right, I'm going to prove to you that the rate of change between all of them is going to be constant. It's the same because this is a linear function. So let's check the output and the input between the first 2 points. To go from 0 to 34.5, you would add 34.5. To go from 0 to 3, you're going to add 3. So the rate of change between these 2 points, if these were on the graph, would be 34.5 divided by 3. All right, because it's a change in output over the change in input. All right, and when you divide those two numbers, 34.5 divided by 3, the answer is 11.5. Okay, now let's check the rate of change between the next two set of points. The change in output, when you go from 34.5 to 57.5, well, let's say we didn't know that off the top of our head. Then we can subtract, right? 57.5 to find the difference between them. It would be 57.5 minus 34.5. Okay, and when you subtract those two numbers, you get 23. So you're adding 23. And then here, to go from 3 to 5, you're adding 2. Well, if we calculated the change in output over the change in input, 23 over 2, when you divide that, is also 11.5. Okay. Let's check the rate of change between the next set of ordered pairs from our table of values. To go from 57.5 to 92, let's say we didn't know off the top of our head what that was. Let's do the subtraction. 92 minus 57.5. Okay, you have to borrow a couple of times. And you're left with 34.5. All right, so you're adding 34.5. And then to go from 5 to 8, you're adding 3. So that was kind of like the rate of change between the first 2 points. See how you added 3 on the input and you added 34.5 in the output? So we already had these numbers, plus 3 and plus 34.5, so we know that that would be the same calculation as this. The change in output is 34.5, and you divide it by 3, which is 11.5. So the rate of change is constant between any two of our points. Okay, so the rate of change for relationship B is 11.5, and the rate of change for relationship A is 9. So which relationship has the greater rate of change? Relationship B, because 11.5 is bigger than 9. So relationship B has the greater rate of change. Make sure you have that. Okay, and then the next question, which relationship has the greater initial value? Well, remember the initial value is the y-intercept. So if we look at our first relationship, our first function, y equals 9x, well, we know that the y-intercept is when the x value is 0. So if you were to plug in 0 into this equation, 9 times 0 is 0. So the y-intercept is 0, right? There is no number by itself here. We have our slope is the number with the x, and then the y-intercept is always the number not with the x, but there is no number not with the x. So the answer for this one, the initial value, is 0 for this function, function A. And then the initial value for relationship B, again, it's when x equals 0. What's your y value? When x equals 0, your y value is also 0. So wait a second. The initial value for function A is 0, because that's what the y-intercept is. And the initial value for relationship B is also 0. So which has the greater initial value? Well, function A has an initial value that is equal to function B. Right? Both of their initial values are 0. They're the same. So function A has an initial value that is equal to function B. Okay, make sure you have all of the correct work with the correct answer, and then you can go on to example number 2.